All right, question 16. Bit of a bummer of a question. So, we've got three sides. We don't know which one's the longest, so I'm just going to let n equal 2 and figure out which one's the longest. So n squared plus n plus 1 is going to come out as 2 squared plus 2 plus 1 gives me 7. 2n plus 1 is going to be 2 times 2 plus 1, 5. And n squared take 1 is 4 take 1, which is 3. So this one's the longest, n squared plus n plus 1. And then I've got 2n plus 1 and n squared take 1. And this is the angle I'm trying to find because it's opposite the largest side, so it's the largest angle. So I'll have n squared plus n plus 1 squared equals n squared take 1 squared plus 2n plus 1 squared take 2 times n squared take 1 times 2n plus 1 times cos theta. So if I rearrange that, I've got cos theta equals, I'll have n squared take 1 squared plus 2n plus 1 squared take n squared plus n plus 1 squared over 2 times n squared take 1 times 2n plus 1. Okay, I'm just going to figure out what each of these squares is on the right hand side. So n squared take 1 squared is n to the 4 take 2n squared plus 1. 2n plus 1 squared is 4n squared plus 4n plus 1. And n squared plus n plus 1 squared, we're going to have to actually expand this because it's not binomials. N squared plus n plus 1, n squared plus n plus 1. So I'm going to get n to the 4 plus n cubed plus n squared plus n cubed plus n squared plus n plus n squared plus n plus 1, which gives me n to the 4 plus 2n cubed plus 3n squared plus 2n plus 1. Okay, which means this thing equals cos theta equals my n squared take 1 all squared was n to the 4 take 2n squared plus 1 plus n plus 2n plus 1 all squared, 4n squared plus 4n plus 1 minus that thing squared came out as n to the 4 plus 2n cubed plus 3n squared plus 2n plus 1. Just going to draw a box around these. And this is all over 2 times, now I'm going to expand these bottom brackets, so that's 2n cubed plus n squared take 2n take 1. So I'm just going to rewrite this top line, n squared take 2, n to the 4 take 2n squared plus 1 plus 4n squared plus 4n plus 1 take n to the 4, take 2n cubed, take 3n squared, take 2n, take 1. All over, these are all times by 2, so I've got 4n cubed plus 2n squared, take 4n, take 2. So that's cos theta, so cos theta. Okay, let's go through. N to the 4 minus n to the 4 disappears. Now let's look for n cubes. I've only got this one, I think. So I've got negative 2n cubed. Now let's look for n squareds. Negative 2n squared plus 4n squared, take 3n squared. So negative 2 plus 4 is 2, take 3 is negative 1. So take n squared. Now let's look for just n's. 4n take 2n plus 2n. Now let's look for whole numbers. 1, 1, minus 1. So we get plus 1 all over. Ooh. Has anyone else noticed something? If I leave this as this, you're going to see where we can start simplifying very soon, because it's just a matter of taking the negatives out of the top line. So don't forget, when you take a negative out the front, you're changing all the signs inside. Which means these cancel out and we get -1 over 2. Oh, they went there. No, oh, those. How I feel personally attacked by that question. Okay, so theta equals arc cos -1 over 2 should come out as 120, but let's chuck it in our calculator. It's 120. How dare they?